you are asked to determine the mass per unit length of a given wire by taking only one measurement using a sonometer and tuning fork. Figure shows a standard sonometer setup used in a school laboratory fixed with the given wire. The wire is stretched with a tension T between two bridges A and B. In this setup, the bridge A is fixed and bridge B is allowed to move. The tension in the wire could be changed by varying the load mass capital N. A tuning fork with unknown frequency is provided to you. Part A. What type of vibration is produced in the surrounding air due to the vibration of tuning fork in this experiment? We know that when vibrating a tuning fork, there is a wave in air medium. It is a sound wave. Then sound waves are making longitude vibration. Therefore, we can write type of vibration longitudinal vibration. We have to write only vibration type. In part B, if simple m is the mass per unit length of stretched wire of tension T, write down an expression for the speed v of transverse waves on the wire in terms of T and M. Velocity of transverse waves in a stretched wire is square root of tension divided by mass per unit length. Simple m is mass per unit length. Then part C. In this experiment, you are supposed to measure the resonance length L of the wire resonating with the tuning fork at the fundamental note. The student suggests that there can be three ways, A, B and C, of keeping vibrated tuning fork to obtain the resonance state as shown in the figure. XY represents the part of the surface of the sonometer box. Part A, tuning fork held normal to the XY and touching XY. Part B, tuning fork held normal to the XY without touching XY. Part C, tuning fork held above the stretched wire. In order to obtain maximum amplitude for resonance out of the above three ways, which way would you select to keep the vibrated tuning fork, A, B or C? Few reasons for your selection. We know that when getting vibration of sonometer wire, we have to place the tuning fork on the sonometer box as figure A. Because of we have to transfer maximum energy from tuning fork to sonometer box. Then we can write answer A and we have to write the reason. Reason is to transfer the energy efficiently. Then part D, write down other items that you normally use in this experiment to detect the resonance state experimentally. We have to use the paper idler. Paper idler means a small piece of paper. We have to place paper idler on the sonometer wire and we can use this paper rider to identify resonance state because of the wire is vibrating with maximum frequency. This paper rider is moving away. Part E. Write down the main experimental steps you follow to determine the optimum resonance state. First of all, we have to place the paper rider on the sonometer wire. Then we can write first step. Place the paper rider on sonometer wire. Then we have to place the vibrated tuning fork on the sonometer box. Then second step is place the vibrated tuning fork on the sonometer box. Then we have to increase the gap between two bridges up to the paper rider is moving away. Then we can write adjust or increase the gap between A and B. A and B means bridges. They have named A and B. From 0 up to the paper rider is moving away. They have given A is the fixed bridge and we can move B. Therefore, we have to use bridge B to increase the gap between A and B. Especially we have to write, we have to increase the gap from 0 because of we have to get the fundamental frequency. Fundamental frequency means minimum vibrated length, minimum vibrating length. We can observe minimum vibrating length by increasing the gap between A and B from 0. Then part F, obtain an expression for M. M means, simple M means linear density. In terms of F, L and T. F is the fundamental frequency. It is equal to the frequency of tuning fork. L is the resonance length. T is the tension. Now I will draw the wave pattern related to fundamental frequency. It is like this. This is bridge A and this one is bridge B. We have to measure this resonance length by using meter ruler. And we know that there is only one loop in wave pattern, therefore it is equal to half of wavelength. It is equal to half of wavelength. Sandaruwan. Then we can get half of wavelength. One loop is equal to half of wavelength. Half of wavelength equals to length of the vibrating wire. Then we can subject lambda. Wavelength is 2L. Now we can use V equals F lambda for the corresponding wave. It is a stationary wave. Stationary wave means the waveform is not moving after this B end of wire. There are two waves. First one is incident wave and second one is reflected wave. Incident wave and reflected wave are making a stationary wave pattern according to the principle of superposition. Then we can write velocity of wave in string T over m root, tension over linear density. Frequency f, wavelength is 2L. Then we have to subject simple m. I will get the square of equation. T over m equals 2 squared 4 f squared L. Now we can subject simple m. M equals T over 4f squared L. 4f squared L squared. We have to get L squared. Then part G, if the resonant length that you have obtained in this experiment is small, how do you adjust the above sonometer setup in a suitable manner to obtain a reasonable large resonance length of the given tuning for the given tuning fork? We know that the measurement is this length. When the measurement is a small value, there is a high percentage error. Then we have to write a method to increase the resonance length. We can observe this equation. When considering this equation, we can observe that square of length is directly proportional to tension. Square of length is directly proportional to tension. Therefore, we can increase tension of the wire to obtain a high resonance length. To increase tension, we can use the mass, use an additional mass as simple as. Then we can write increasing the weight of the load. So part H, when capital M equals to 3.2 kilograms, frequency f 320 Hz and the resonance length was found to be 25 centimeters. Find the mass per unit length of the wire in kilograms per meter. Mass per unit length means mass divided by length of the wire. Then we can use this equation directly. Simple M equals T divided by 4f squared L squared. We have to substitute values. Mass 3.2 into G10 divided by 4 times square of frequency 320 into 320. Length of wire 25 centimeters. We have to divide it by 100. Again we have to put 25 over 100. There are square terms. Now we can simplify it. 3.2 divided by 3.21, 320 divided by 3.2, 100. We can cancel out 100 and 100. Again we can cancel out 0 and 0. 4 times 1, 100 divided by 4, 25. We can cancel out 25 and 25. Then answer is 1 over 32 into 25. We have to simplify it. Answer will be 1.25 into 10 to the power minus 3 kilograms per meter.